Hello everyone, welcome to the lecture series of circuit analysis. Today we are going to see about Unit 1 DC circuit analysis. In this unit, we are going to analyze the elements in the DC circuits. First, DC current. It is an electrical current which flows consistently in one direction. DC current is a current which only flows in one direction. It doesn't depend on any other direction and doesn't flows on any other direction. So the current flows that in a flashlight or any other appliances running on batteries is direct current. In our battery, in our home, we are using batteries for charging our TV remote or wall clock, etc. Those batteries are known as DC current batteries. In that battery, we are storing a DC current in it. DC means direct current. Direct current, the name itself says it flows only in one direction. Direct current. Example of direct current is electric vehicles, cell phones, electronic welding appliances, mobile phone batteries, flashlight, etc. These are the examples of DC current circuit. Let us analyze the DC circuit, DC current circuit. In this circuit, one battery is attached in series with battery and switches are connected to it. A voltmeter and ammeter are also connected to this circuit. Voltmeter is used to measure the voltage and an ammeter is used to measure the current. In this circuit, the switch can operate as open and source element. When the switch is open, the battery current doesn't flow through this circuit. When the switch is closed, the battery in the current in the battery flows through the circuit and enters voltmeter and ammeter. Basic terms in electricity. Electricity has some basic terms like charge, current, voltage, power, energy, etc. Let, let we learn about the symbol, unit for that, and formula and that notation of that. First one is charge. Charge symbol is Q and its unit is coulomb. Coulomb is represented as C. It has no formula and notation. Current is denoted as I. Its unit is ampere A. Its formula is coulomb by second. Then flux. Flux is denoted as phi. Its unit is Weber, WB, capital W and small b. It has no formula and notation. Then voltage. Voltage is denoted as V. Its unit is volt and it is represented as capital V. Its formula is work done divided by charge. Its notation is W, capital W divided by capital Q. Then power. Power's symbol is P. Its unit is watt and it is denoted as capital W. Its formula is joule by second, J by S. Then energy. Energy is represented as E. Its unit is joule, J or kilowatts per hour. Its formula is power into time. Notation is watt second or kilowatt per hour. Then resistance. Resistance is represented as R. Its unit is ohm and its formula is voltage divided by current, V by I. Then inductance. Inductance is denoted as L. Its unit is Henry H and its formula is Weber by ampere, WB by A. Then capacitance. Capacitance is denoted as C and its unit is Farad, F, and its formula is Coulomb by volt, C by V. Then time. Time is represented as T. Its unit is seconds, SEC. It has no formula and notation. Frequency is denoted as F. Its unit is hertz. It is denoted as HZ. Its formula is cycles by seconds. Angular frequency is represented as omega and its unit is radian per second and it has no formula and notation. Temperature is symbol is temp. Its unit is Celsius. Electrical circuit. Electrical circuit is the closed path of electrical components and wires which allows current through it. Electrical components like resistors, capacitors are connected in a circuit is known as electrical circuit. Then voltage. Voltage is the difference in the electric potential between 2 points. If we consider a point A and B, the difference between the electric potential between these 2 points are said to be a voltage. That pulses charged electrons through a conducting loop. It is a current pushes through the charged electrons and it is denoted as V. Then current. It is the rate of flow of charge. Current is said to be a rate of flow of charge. And resistor. It is the component that offers resistance and it is used to resist the voltage drop across the circuit. Then resistance. Resistance is the measure of opposite to the current flow in an electrical circuit and its unit is ohm. Then inductance. Inductance is the property of a material by which electrical energy is stored in the form of electromagnetic field. Inductance is the storing element which stores the energy in the form of electromagnetic field. That is said to be an inductance, where the voltage across an inductor is directly proportional to the rate of change of current. In this stanza, they are telling the voltage is directly proportional to the rate of change of current. And finally, capacitance. Capacitance is the element which stores the applied energy in the form of electrostatic field, where inductance stores the energy in the form of electromagnetic field and the capacitance stores the energy in the form of electrostatic field. We can further discuss about the electromagnetic field and the electric field. Capacitance is the amount of charge stored in the capacitor is directly proportional to the applied voltage. Then charge. Charge is the amount of energy or electrons that passes from one body to another. Let we see the symbols for all the electrical components. First one is resistance or resistor. Resistor is denoted as R and its symbol is this, a triangle shaped symbol it is. Then DC voltage source. DC voltage source can be represented in three diagrams. They are one long line and one short line. Long line denotes the positive and short line denotes the negative. It is also a voltage source, DC voltage source. If the arrow mark is like this, it is said to be a variable voltage source, variable DC voltage source. Then DC current. DC current symbol is this and it is denoted as I. Then variable resistor. Normal resistor is denoted like this and the variable resistor is denoted like this and it's represented as R. Then inductor. Inductor is denoted as L and its symbol is this. Then capacitor. Capacitor is denoted as C. Then voltmeter. Let us see the definitions of the network. When the network, the arrangement of various electrical source along with the different circuit element to perform any specific operation is called an electric network. Here, an example electrical network is given, where the three nodes are said to be named as A, B, and C, and resistor 1 is R1, 2 is R2, and 3 is R3. And there are two power source. The power source 1 can be represented as E1 and E2. It can be also represented as V1 or V2. V1 or V2. Then node. A node is a point in the network where two or more circuit elements are joined. Here, these two elements are joined in this point, so it is said to be one node and it is denoted as A. And here also three resistors are connected in one point and that point is taken as a node. And here also this point is taken as a node. So we have four nodes A, B, C and D. D also having connected with the R3 and E2. So it is also considered as a node. Then junction. A junction is a point in the network where three or more circuit elements are joined together, where B and D are junctions. Why B and D are junctions? B is connected with R1, E1 and R3, E3 and R2. So it is connected with more electrical elements. So it is said to be a junction. Then branch. The part of a network which lies between two junction points is called branch. Branch is a part of a network which connects two junction points like AB. It is said to be a branch. Then BD, BC and DA are said to be as branches. Then loop. The closed part of a network is called a loop. Let us consider A, B, D, A. This is the one loop where current flows from here to there. It is denoted as like this. It is one loop. Then mesh. A mesh is a loop which does not contain any other loop. The most elementary form of a loop which cannot be further divided. Where in the circuit ABDA can be represented as mesh because this is a loop which cannot be further divided. So it is considered as a mesh. Now, classification of electric networks. Electric networks are classified into 8 networks. They are linear network, non-linear network, bilateral network, unilateral network, active network, passive network, lumped network and distributed network. Where linear network is a circuit whose parameter are elements like resistances, inductances and capacitance are always constant irrespective with the change in time, where voltage and temperature etc. is known as linear circuit. Where nonlinear circuit is a circuit whose parameters change their values with the change in time. Okay, yeah. It is irrespective with the change in time. It is respective with that change in time with the temperature, voltage, etc. Then bilinear network. Bilinear network is a network whose characteristics behavior is same irrespective of direction of current through various element of it. And its example is resistive circuit. Then unilateral network. Unilateral network whose operation behavior is dependent on the direction of current, where bilateral network is irrespective of direction of current and unilateral network is dependent on the direction of current flow. Its example is circuit consisting of diodes which allows current in only direction. Diode has the ability to uh, direct the current in only one direction. So it is used in unilateral network. Then active network. A circuit which contains at least one source of energy is called active network. One source of energy source like voltage source or current source. An energy source may be voltage source or current source. Then passive network. A circuit which contains no energy source is said to be a passive network. In this circuit, there is a known energy source. In this circuit, it is the example circuit of active network and it is the example circuit of passive network, and it does not have any energy source. Lumped network. In this network, the elements are physically separable. Most of the electric networks are lumped in nature, which consist of elements like RLC and voltage source. Then distributed network. In this network, the circuit elements like resistance, inductance cannot be physically separable. It is physically separable and it is not physically separable. For any analysis is called distributed network. Example here, transmission line where the line parameters like RLC are distributed throughout the line and cannot be shown as a separate element anywhere in the circuit. Here, one electric network is connected with both active and passive, linear, non-linear, and another electric. Now, active elements. Active elements produces energy in the form of voltage or current. If any energy producing voltage is current is said to be an active element, where passive element is an element which stores energy, where active elements produces energy and passive elements stores the energy. Example, resistor, inductor, capacitor. can be used to store the energy in this circuit.